Hi dear viewers and students to my channel Mathematics Made Easy, and today we have Mathematics Made Easy presents 10 days of trigonometry. So as per my last announcement that I made on my channel, today we are starting with day 1 of the trigonometry session. So before we move forward, a humble request for all my dear viewers and my students, those who are liking my videos, finding them useful and helpful in the journey of learning mathematics, please make sure you hit that subscribe button and press that bell icon. So let's get to know our first problem for today for day 1 of the session. Okay, so this is our problem for today on day 1 of our trigonometry series. We have a clock problem in front of us, and this is how it goes. Through what angle? We need to find the angle in the two units, number 1 degrees, number 2 radians. Does the hour hand of the clock rotate between 4 p.m. and 7 p.m.? So when we are reading a word problem, we read it slowly, nicely, and highlight important information. That's a tip from my side. Now assume that the length of the hour hand is 6 inches. So this length is given to you. Find the arc length of the circle made by the hour hand during that time. So this is how a clock looks like, and we're looking at the hour hand. So the smaller one, this one is the hour hand. Okay, and what time is given? 4 to 7. So I'm going to draw a little bit on this clock by dotted line. So this is 4 and this is 7. So from 4 to 7, that means this is the direction for the angle theta that we need to find here. So now because theta is going in the clockwise direction, so we can take the value of the angle to be negative by convention. Now we need to find this angle both in degrees and radians. So let's go for the angle now. So theta, this is representing the angle from 4 to 7. Now the two units that we are looking at is degrees and radians, and before we find this angle, let's see what is the relationship between these two units. So one complete rotation of the needle represents a complete circle, so that represents 360 degrees, or you can say 2 pi radians, correct? And now because if you see the clock, it is divided into 12 equal parts starting from 1 2 3 4 5 6 7 8 9 10 11 12. So 12 equal parts. So let's try and find the measure of one division first, right? So I'm going to divide here by 12. That's what you get. So one division on the clock, which is moved by the hour and represents an angle of 360 degree divided by 12, so that's 30 degrees, or in radians if you want to say, it is going to be pi over 6 radians, right? So this is all about one division. Now if you look at the clock moving from 4 till 7, so one division, two division and three division. So if you see, it has moved by 3 units or 3 divisions. And also I told you in the beginning that here the direction is clockwise, and if you look at the sign convention for angles, you know clockwise is negative angle. So 3 divisions is representing 3 multiplied by 30, and the sign is negative, so negative 90 degrees, or negative 3 multiplied with one angle pi by 6, so this is negative pi by 2 radians. Okay, so that completes our first part of the question, where you had to do the angle in degrees and radians. So in degrees it has come as negative 90, and in radians it has come as negative pi by 2. Okay, so that was complete first part. Now we move on to second part where we need to find arc length. So arc length is represented in trigonometry with a small s. What is the formula? R times theta. R is my radius, theta is my angle. So radius here actually represents nothing but the length of the hour hand. And how much it is given in the problem? 6 inches. So we are going to plug in that 6 inches in place of r, and for theta we can put the angle. Now angle we've got in degrees, we've got in radians, so you can do any one of them. So when I do in degrees, I multiply with this, so you can get negative your arc length as let's multiply So 54 degrees. Now, can arc length be negative? It's representing a distance. So therefore, the final answer can be in positive sign, okay, because it's a length, it's a distance, it cannot be measured negatively. So this is the final answer. The length of the hour hand you took at 6 inches, and you found the arc length of the circle made by the hour hand using this formula S equal to r theta. So that completes your answer. Just think about how you can use the same formula and use the angle of radians to get your answer in radians. I hope you enjoyed solving this problem with me. Until then, this is Mr. Chika signing off from today's session. Thank you for watching. My way of solving the trigonometry problem. Don't forget to like, share and subscribe with other friends of yours who have similar interests. This problem pertains to grade 9 and 10. So all my viewers, thank you so much for liking and subscribing to my channel. Until then, Mr. Chika signs off from today's session. Bye-bye.